Hello and welcome back to my video series on why I believe the Pokemon Reborn AI method, SelfStatBoost, needs to be adjusted. So in my previous video, I laid out my reasons for why I believe it needs to be adjusted. To briefly recap that video, SelfStatBoost is the method the AI uses to calculate move-based stat stage boosting methods. So stuff like Defense Curl, Calm Mind, Leaf Storm, etc. To do this, it calculates a value known as the base mini score, specifically for status boosting moves. Basically, this replaces initial score calculation so that you don't have to get damage, and it reduces the hard coding required from PB stuff status damage array. In general, this is also a good idea because it makes moves that boost more stats worth more than moves that boost less stats. So stuff like Shell Smash is better than Charge or Defense Curl. So to look at the current process, you can see here it's just the sum of the stat stage changes. So Shell Smash gets to +4. This can get very out of hand very quickly, especially because SelfStatBoost itself, as in the rest of the method, has quite a large number of additional multipliers that are added to it. As such, I was sort of given the green light to potentially adjust it. So I outlined the project goals here. So number 1 was to moderate SelfStatBoost's base mini score values for more extreme boosting moves. So stuff like Coil, Quiver Dance, Shell Smash, and especially when you start bringing field interactions into play, as Coil on Grassy, Quiver Dance on Big Top, stuff like that. As you can see here, only a handful of status moves have an initial score of 30 or above. These include some really heavy hitters like terrain setting moves, Glare, Encore, screen moves, Tailwind, Spore, Sticky Web, hazards and stuff. With that said, quite a large number of status moves can also hit that threshold, can hit that 30 threshold. In vanilla, Coil, Quiver Dance, Shell Smash, Tail Glow, and then a few others. And then when you add in field interactions, you can get an even larger number hitting that 60 score threshold. So Quiver Dance on Big Top is worth as much as Aurora Veil initially, and then quite often gets a 6 to 10 additional multiplier, which can lead to total move scores around the few hundreds to, I think it's potentially hypothetical to get a base mini score of over 1,000 for some of these stat boosting moves. Anyway, I just want to keep that from being overly common with setup moves, especially when you get into those more extreme boosting options. Going hand in hand with that, I want to make the AI understand that setup has diminishing returns. I showed some example calcs here. You don't need to go above these stats to OHKO my example Meganium, but even if you ignore specific calcs, the power boost from going from +0 to +2 attack is doubling your attack stat, whereas the power boost from going from +4 to +6 is only about a 33% increase. So with those goals in mind, let me go into the 5 options that I have developed to look at. So option A uses a similar process to the current method. It would count the number of stages, just one stage equals one base mini score, until some certain arbitrary number of stages. In this example, or in this code, I used the value of 3 for the arbitrary cap. However, again, that value could be adjusted as arbitrary. Beyond that number of stages, each additional stage is worth a constant fraction of a stage. So in this example, I used 1/3, although again, you could choose more or less depending on what you want. Option B, I put option in air quotes. I'm not considering option B to implement. However, you'll see why sort of when I get into the case studies, but it is the basis for options C, D, and E, and so I figured it would just be easier to explain option B and then explain how options C, D, and E differ from option B. So yeah. So in essence, option B finds the ratio between the current stat stage multiplier and the stat stage multiplier that the Pokemon will have after using the boosted move. So you get the 50%. So if you get a 50% boost from going from +0 to +1, it calculates that. Then it subtracts 1 from that ratio just to isolate sort of that percentage increase, and then repeats that for each stat and sums it. Like I said, this option is not a real option because the values of returns tend to be extremely low, lower than even current, and even for low moves, though again, you'll see more of that in specifics in the case studies. So option C is based off of option B, but before it finalizes the base mini score, after it calculates all the stats, it calculates all the ratios, and then it sums them. But then it also adds 1 to sort of represent a baseline power ratio of 1.0, as in you won't lose anything at any point. So option D does something even more different. It sort of converts the stat stage ratio into an equivalent number of stages by dividing by some constant. For that constant, I used 1.5, which is the ratio between +1 and +0, which I considered sort of a good baseline for, for the power increase from a stage. Obviously, that number is arbitrary. It could be more or less depending on what we want, depending on what we ultimately decide, but that's sort of what I went with. And then for the fifth option, we have option E, which sort of combines the above methods. It's based off of option D's idea of converting to an equivalent number of stages, but instead of using just the ratio, it subtracts 1 from that ratio, like option B and C, and then divides to isolate sort of the power boost and remove that baseline 100%, as in like, so it's just looking at how much you increase in power, and then it divides that by the power boost even at a +0 to +1 stage. And then it does that for all the stats, and then sums them all, and then that's the total base mini score. So, moving into the case studies. Below will be 10 invented scenarios that I calculated out in Excel, and then an in-game test using turns 1 and 2 of Appo's Psycho Bug. I'll get more into that bug when I come to it, just to sort of explain it, but yeah. So, case study 1 is looking at the move Howl. So, a Pokemon wants to use Howl. It calculates the base mini score for that. So here, we can see the current attack stage that the Pokemon using Howl is using. And then we can see the base mini scores that each option returns. So option A here in orange offers no change from the current or vanilla version. In fact, I did graph the current method. It's just covered by option A. Option B here in green, in dark green, returns values much less than 1 for all stat stages. So it basically halves the current value, and that's for Howl. And that's why I said that option B wasn't a real option, because this implies that you were losing power. Option C returns higher than vanilla, which does make me question it, but option C is one of the better options, and you'll see that in future case studies. So option D looks like it has the best balance out of them, around 0, stat stage 0 and stat stage -1, so at -1 attack and 0 attack, you get like a big boost, and then you get some slight diminishing returns towards the edges, as you can see. So you don't really want to set up when the opponent's debuffed you all the way down to -6, and then going up to, and then if you're at say like +5, setting up is less good. And finally, option E has very extreme stat stages. So like you can see here, the base mini score is around 1 at 0 or -1, so the same as the current, but then it's all the way down at like 0.33, 0.25, somewhere in there when going from +5 to +6. For option 2, I looked at agility, though any non-accuracy or evasion move that boosts one stat by 2 stages would return the same values. As you can see, option A is once again identical to the present value. Option B returns very, very low values. Option C returns somewhat reasonable values. And then option D returns more dampened values, but yeah. I'm not really sure how to what we're thinking on option B or C versus D. So yeah. And then option E, you get this huge spike in the center, and then it rapidly drops off. Yeah. Option 3, for study 3, I looked at acid armor on Murkwater. However, again, any non-accuracy or evasion move that boosts the stat stages by 3 could work. So Tail Glow, Swords Dance on Fairy Tale, so on and so forth. So again, option A is identical because we don't go above 3 total stat stage changes. Option B returns values that are quite low, as you can see here again. You get all the way down to like 0.025 when you're at +5. You get, Option C once again has pretty decent values. And then option D also has pretty decent values, but they are somewhat low and at a lower but they do have a lower diminishing rate than option B. And finally, of course, option E, you get this big spike and the very, very big drop off. So for option 4, or for study 4, we have Belly Drum. Belly Drum is one of the moves that is a major outlier in the general formula, and that's part of the reason why I was like, this is questionable. Or why I was like, SelfStatBoost kind of maybe needs an adjustment. So first off, I did not show option E, as its value for when you're at -6 was 30, which equates to an initial score of 300, which is a bit too high. Similarly, you can see a lot of the methods here. They're very high values here, even up to -1. So as you can see here, the current Belly Drum is very high, especially if you debuff the Belly Drummer, if you debuff the Belly Drummer's attack stat. Options C and B and C are basically identical because, again, these values are very big, and so a +1 increase is a much lesser effect. But they do get above Belly Drum at some of these lower stat stages, even though they do decrease and dampen the effects at lower ones. Option D here moderates the effects sort of at all levels, and then it does have that sort of diminishing returns down here, down once you get to positive stat stage changes. Option A moderates the best, but option A was sort of designed around these more extreme circumstances, and it doesn't really have that diminishing rate. So Belly Drum C, even at +3, would have a base mini score of 3, which is basically which again is an initial score of around 30. So yeah, for study 5, for studies 5 and 6, I wanted to look at how accuracy and evasion would mess with these options, because accuracy and evasion use a different formula for the stat stage multipliers than normal stats. So you can see here double team. It's a similar curve to the Howl one, but with lower general values because each stage is a smaller boost with accuracy and evasion than, say, attack, defense, speed, etc. So as you can see here, option B, air quotes there, option B is very, very low. Option E is also quite low and gets very, very low. Option C returns values higher. Option D returns values here, and then option A is identical to the current method. So for study 6, I looked at minimize. It's basically the same as study 2, which was agility, just with slightly less just with like general dampening. I think I don't really have any more comments besides that. It's like option B is very low, option D is about 1. So, option E has this very big peak in the center that goes down. Option C is sort of higher than the rest of them for these low values. So moving on to actual new stuff. So for study 7, I looked at bulk up to examine how 2 stats would work, how boosting 2 stats would affect the base mini score. So similar to the other studies, option A returns with this unchanged graph. As you can see here, I sort of plotted each method. So now A, B, C, D, E, and then one by each stat's current stat stage. So option A is unchanged from the current. Option B returns very low values just across the board. Option C and D look like the best to me, once again. As you can see here, option D does get these low values at the very extremes when one stat would no longer be boosted. Option C does not. But they both get this sort of spike around when you're at -1 to 0 stages for both, and then gradually diminish as you approach the extremes. And then finally, option E, as you can see, it drops off very far compared to options D and C, even though you get sort of the same spike. Moving on, we then, for study 8, I chose Calm Mind and Psychic Terrain, though any move that boosts 2 normal stats by +2/+2, such as Cosmic Power on Psychic Terrain, trying to think of any non-field interactions. Oh, Shell Smash, when you aren't a mixed attacker and stuff, would also work. So similar to study 7, you sort of get the same things, but but this one also shows how each method moderates more of those extreme stat boosts that I was talking about. So as you can see here, option A, option E returns higher values at certain thresholds, and then it very rapidly drops off. Option D, both options D and C moderate that value quite well, and then also have the diminishing returns. Options A does moderate, but it's very few diminishing returns. This only happens because the stats no longer increase beyond that point, beyond sort of this boundary. And then option B, once again, it returns extremely low values, just generally across the board, except around the center, and even then, that is quite a low value. So, for study 9 and 10, I decided to look at 2 other allies. They're both Omni-Boost moves. So for study 9, I looked at Clangorous Soul, Z Celebrate, I don't know if Z Happy Hour, Z Celebrate for sure, Clangorous Soul, and then No Retreat, would all basically be stand-ins for this. So at +0, D and E offer no change from vanilla, and that's something to note. The other options do moderate this extremity decently well at +0. However, at +1, all of them moderate, but again, you can sort of see here, E falls off very, very rapidly. B returns quite a low value, and then A, no change. A is identical to what it was at +0, and then C has the good diminishing. So yeah. I also had 6 independent variables for this, so I didn't really include a graph. So you kind of just have this. I will upload an Excel file in the CCI Discord, though, if you all want to mess around with it and calculate. So yeah. And then for study 10, I chose Extreme Evo Boost. This is the single highest current base mini score with a value of 10. It boosts 5 stats by 2 stages each, 10 stat stages. Once again, I have no graph because of the high number of variable counts, and I don't think we can graph 7 independent variables or a 7-dimensional system. No, a 6-dimensional system in Excel or PowerPoint or really anything. So, anyway, the value for Extreme Evo Boost peaks when all stats are at -1. This is because the greatest number of 2-stage stat stage multiplier changes between +1 and -1 with an increase of 2.25, blah, 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 that's math. That's math, I'm getting off track. Anyway, as you can see here, option E returns a value higher than the current. So I don't think option E is very good. Option B returns value significantly lower than the current. Option A also returns value significantly lower than the current, but this would be the same even if you are at, say, +4 for all stats. And so option A doesn't really diminish the returns, and so, yeah. So, you can see here, options C and D return what I believe are the best ones, are the best values. About 3/4 of the current value, so it's diminishing, but it is but extreme EvoBoost is admittedly a very strong move. And then at +0, you can sort of see like how things fall from there. So option D goes down slower than option C. Option B is again very, very low. Option A is unchanged, etc. So, sorry, I said there were 10. It's 11 case studies. And so for the final case study, I chose coil plus grassy terrain. Basically, familiar pattern by now. You can see I adjusted the accuracy stage modifier, but that's whatever, just to make this easier to look at. Option E doesn't really dampen the values. If anything, it makes the higher stat towards more normal values, and then very, very rapidly falls off. Option D and C have pretty well moderated values and then slight diminishing returns. Option A does not diminish the values at all. It barely diminishes the values, but it does moderate the values. And then option D over here, not option D, option B over here just returns extremely low values in general. And so, yeah. So, and then finally, for study 11, I was looking at Apo's psych-up bug. So, for those unfamiliar, this psych-up bug involved a Ribombee not going for a pollen puff guaranteed KO to win the battle against a solo Umbreon, and instead going for psych-up onto its partner Cosmoem. Cosmoem would always use Cosmic Power on turn 1 to get the +2 to both defenses, and then Ribombee would analyze looking at psych-up to copy those boosts. So for both turns 1 and 2, I looked at the return that total SelfStatBoost gave, the base mini score, and then other modifiers. Now, these other modifiers don't really matter. I just included them to show that the situation was the same throughout every scenario, throughout all these different options, and so the only change in this return would be the base mini score. So, the current method in-game had a base mini score of 4 on turn 1, which would be +4 special attack. And then in turn 2, it would be the +2 defense, +2 special defense for a total base mini score of 4. Option A returns the same values. Option B returns the same values as well. As you can see here, 3 stages at +1, 3 full stages, and then an extra 1/3 of a stage for both turns. Option B would return, and once again, quite low values of mini scores at +2. So, yeah. Option C returned a pretty decently moderated value. What else am I saying? Yeah, so option C returned a pretty decently moderated value. And then because of how this is working, I'm not sure how the diminishing returns applied. For option D, you can sort of see it values the defense boosts more than it values the just boost up the special attack. Implying that option D does have a decent diminishing returns function, and it moderates both, and it moderates the total peaks. And then finally, for option E, we get values identical to the current in-game, implying no moderation. Though, again, I would expect the diminishing returns of option E to be extremely high. And so, yeah. My favorite option out of these is option D. I think it strikes the best balance between more extreme examples, more moderate examples, such as the agility ones, and those +1 stat boosts, like Howl or Defense Curl and stuff. Now, I will say that we can adjust some of these ratios and stuff, especially for options D and E, where, you know, again, this 1.5 value is completely arbitrary. This 0.5 value is arbitrary, and so on and so forth. We can also adjust it specifically for evasion accuracy, and so on and so forth. But yeah, I'd love to hear your thoughts, and I do want to hear your thoughts. So yeah.